recording. There we go. Yes, of course. Okay, so this is on page 27, and at the bottom of the page, yes. Yeah. So we have a single unit, and we will actually often focus on a single unit. How likely is it to actually end up in nature with a single unit of an ionic compound? Super unlikely, okay? Not likely at all, okay? But if we do, we call this single unit a formula unit. And a formula unit is like a molecule, but for an ionic compound. But you should always keep in mind that what we're really dealing with is this lattice structure, L-A-T-T-I-C-E. But more often you're going to hear it referred to as a crystal lattice. And if you've ever looked at salt crystals, you'll know why it's called a crystal lattice, because they are literally crystals. So you guys could do page 29. Okay, and then we will, after about 5 or 10 minutes on that, we'll move on to our next thing. Okay. Now, folks, on page 17, I don't know if you all noticed it, but there is a trick question. Yes. And the trick question is G, because G is not a mixture. It is a pure substance. Okay, so if you got tricked by that one, it's because I wasn't playing fair. I said it would be a heterogeneous mixture or homogeneous mixture, and that one was neither. But I did it on purpose because I wanted to see if you were paying attention, see if it made sense to you. Okay, we are going to move on to page 30. Not a whole lot. We were mostly working on stuff. So yeah. Okay, so page 30. So we're going to be looking at writing names and formulas of simple ionic compounds. There's much more complex ionic compounds, but these ones are super simple and they're actually super easy to write the names and the formulas. Who comes first? The metal always comes first. Who always goes second? The nonmetal. So it doesn't matter if it's the name or the formula, it's always the metal first and the nonmetal second. It's the same as the order in the periodic table. The metals are on the left and the nonmetals are on the right. And all you have to do to name it is to write literally the name of the metal, like sodium, and then write the name of the nonmetal, but change the ending to ide. So that would be like the chloride. So if we have a compound of magnesium, which is a metal, and oxygen, which is a nonmetal, we just name it magnesium oxide. Now, if I give you nitrogen, is nitrogen a metal or a nonmetal? It's a nonmetal. So it's going to come first or second? Second. Oh, and I wrote no metal, which kind of is accurate, but is not spelled right. And we have aluminum. Aluminum is a metal or non-metal? Metal. So it's going to come first. And we just name it aluminum nitride. And remember, not nitrogide. Remember, it's always that first syllable plus ide. So that's dealing with the names. Pretty straightforward, yes? Not much to it. Name the metal, name the nonmetal, change the ending to ide. Formulas, there's a little tiny bit more to the formulas, but not a whole lot. We're going to learn a new word here, and that word is subscript. What does it mean if you have a submarine? Where do submarines go? They go below the water, they go under the water. Marine is like water. So submarine goes under the water. A subscript goes below, and the word script refers to writing. So the little subscripts go below the writing. What are they? They are the small numbers written at the bottom of an element, and it tells you how many of that atom or ion. How many? If there is only one, we do not write a subscript. Okay, if it's blank, that means there's just one. So if I tell you a compound forms between sodium and phosphorus, and if I tell you it contains 3 sodium ions and 1 phosphide ion, what's the symbol for sodium? Sodium is Na. And what we're going to do to show that there are 3 of them is we're going to write a little 3 down at the bottom. And phosphide, we're going to write a P. Okay. And because there's only one, we don't write any little number at the bottom. And what it would look like is this would be a formula unit of Na3P, sodium phosphide. Oh, I erased it. That wasn't good. Now, one thing while we're looking at this formula unit, how many positives are in this structure? 1, 2, 3 positives. How many negatives are in this structure? Also 3. There's 3 negatives. If you have a compound is always neutral. The positive and negative charges will always cancel out. The net charge is equal to 0. What does net mean overall? All compounds have a net charge equal to 0. All of them, all the time. And one way we'll express that is we'll say that the charges have to be balanced. We balance out the positive and the negative. Yes? Are there more electrons or protons in the universe? I would guess that they are the same, but I don't know that for sure. You could Google that. Let me know what you find out, because honestly, I don't know. It's a good question, though. So all compounds have a net charge, and we say that the charges are balanced. And when charges are balanced, that means that the positive equals the negative, and therefore, those 3 dots, are we familiar with that meaning therefore? Therefore, overall, we have 0 charge. Absolutely. So this is sodium phosphide. Remember, just one syllable and then the ide. So phosphide. Okay. So this is sodium phos, one syllable, and then phide. Excellent. That would have been my guess, but you know, I hate to make a statement like that because I actually don't know for sure, but now I do. All right. Now, remember, just in case you've forgotten, the element symbols, the first letter is always a. First letter of an element symbol is always what form of the letter? Capital. Second letter is always lowercase. So I don't want to see any of this. NaCl. No. Okay, that is not right. All right. So it's interesting because you can actually look at this and you can say, how many elements is KF made of? There's 2 capital letters. So that is made of 2 elements. K is potassium, F is fluorine. What would the name of that compound be? Potassium fluoride. Now I'm going to show you the most common mistake people do with fluorine. So don't write it down just yet. What have I done wrong? The O and the U, fluoride. It's not potassium fluoride. It should be potassium fluoride. Okay. Not OU. We don't want any fluorides. Magnesium and bromine, we have 1 capital letter, 2 capital letters. So it's made of 2 elements. What would the compound name be? Tell your partner, what is the compound name for MgBr2? Is it iron oxygen? No. What is it? Magnesium. And then bromide. The next one, how many capital letters in this next compound here? 1, 2, 3. And I want you to notice that letter right there is an L. Maybe I'll make that even look more like an L. It's an L, not an I. I've very carefully chosen a font where ones and L's and I's all look different. Okay? That's the number 1. That's lowercase l. And that's a capital I. I know, it's irritating. Sometimes people will look at that and think nitrogen, hydrogen, carbon, and iodine, but it's not. It's C with a lowercase l. So that is 3 elements, and we'll learn how to name the ones with 3 elements later. We're not going to worry about that right now. And again, we have another one down here. We have NaNO3. It's made of 3 elements: sodium, nitrogen, and oxygen. Okay, so here's chlorine. So if we have Cl2, it's actually sodium nitrate, which we'll learn in our next unit. Okay, yeah. So if we have Cl2, first of all, what kind of a substance is this? Is this a compound or an element? Tell your partner. Is that a compound or is it an element? It is an element. What is this type of particle called? That is indeed a molecule. Yes. I'm going to come closer because I can't do it. It is diatomic. Yes, because it is made of two atoms. Okay, so that's chlorine. We have Ki. Here is a formula unit. Of Ki. You'll notice we only have one K and one I. Is that what it would look like in nature? No, what would it do in nature? Would we just have those two little particles together? Two little atoms, two little ions? No. What would it look like? It would look like this. What do we call this? A crystal lattice. Okay. This is a compound because it is made of two or more different elements. And it is made of a metal and a non-metal. And when we have a metal plus a non-metal, what kind of compound is that? That is, I thought I heard someone say it, ionic. Okay, a metal plus a non-metal is an ionic compound. Here I have carbon. Carbon is a non-metal. And iodine is a non-metal. When we have a non-metal plus a non-metal, that's no longer an ionic compound. That kind of compound is called a covalent compound. So when we have a non-metal and a non-metal, that is covalent. Do you see charges up here? Are there charges up here? Yes, because they are ions forming an ionic compound. Do you see charges here? No, that's because that is not an ionic compound. It is a covalent compound. Connor, you had a question? Okay, cool. All right, so we have some exercises here. And I just wanted to do the first couple of number 4 with you. Okay, because I find that when people get to number 4, they kind of go a little crazy. All right, so let's do the first one of number 4 together. We are going to write the formula for these ionic compounds. The metal has to go first, and you're going to use subscripts to show the number of each ion. So when we look at this first one, who is the metal? Is it Br, which is bromine? Or is it Al, which is aluminum? Aluminum is the metal, and bromine is the non-metal. So when we write the formula, who goes first? Al goes first and bromine goes second. So we're going to write Al. And do we have a subscript for Al? No subscript. There's just one Al. And then we write Br, and what do we write beside the Br? 3, because there are 3 of them. So that's how you do this question. Sometimes you'll be given a picture, sometimes you'll be told the number of ions. Just make sure it's always the metal first and the non-metal second. Okay, so take a little bit and work on this page here. And for number 1, you're just doing the name, you're not doing the formula. Okay, so you're not looking for the CAF, you're looking for calcium fluoride. Okay, so just the name for number 1. So folks, we're going to page 40. We're just going to start on this, okay? Page 40, 40. We might not get through all the way through it today, that's okay. Okay, this one doesn't actually have any words. So there will be some writing, but there won't be any dialogue. All right, and we want to tone down the sound just a little bit because it's noisy. going to fill in. Noble gases have complete outer electron shells which make them stable. Because all atoms are trying to achieve stability, and if you put a metal with a non-metal, the metal will give electrons to the non-metal, and the metal will empty itself out, and that will fill up the non-metal. But here we're going to put non-metals with non-metals. Okay, so in order to gain this kind of stability, other non-metal atoms come together to achieve this noble gas configuration. And when we say configuration, we mean the arrangement of electrons. We are on page 40. This coming together and sharing of electrons, okay, coming together and sharing of electron pairs, I should say, not just electrons. You see how they're sharing 2 electrons here? They always share pairs of electrons. And if we count the electrons on the outer shell, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Is that a stable arrangement? Yes, it is. Like the weirdest video ever. Don't worry about filling it in. We'll do that next day, but we'll just watch this until the bell goes. Your homework is just to finish 29 or 32 if you didn't already. So maybe no homework today.
Pardon me? No.